Okay, welcome, Dr. Bhatnagar. Good morning, and thanks a lot, sir, for coming on my platform, YourPedia Education.
Thank you very much for having me, Dr. Vijayendra. It's a
Uh,
pleasure.
yeah, Professor Bhatnagar, I did some kind of homework before I came to interview you, and I have some questions jotted down.
Okay.
And normally, my first question is always related to, sir, your academic journey only. And
Yeah.
I could find that you did your graduation from Ramjas College, Delhi University, in physics, and then you went to IISc Bangalore. So we would like you to tell us something about your academic journey first, sir.
Sure, sure. So before I talk about my academic journey, first, the beginning of my life. So, I was born in Rewa in Madhya Pradesh. My father was a principal scientist in there is this institute called, I think, CIFRI. It's the Central Institute for Fisheries Research or something like that, and which comes under the ICAR, which is the Indian Council of Agricultural Research. And because of that, he had a transferable job, and we were transferred sort of all around the country. So from Rewa, where I was born, we went to Andhra Pradesh and Nagarjuna Sagar, where there was the Krishna River, and then he was transferred to Ranchi in Bihar at that time. And so in Ranchi, we were there during my class 4 to class 12. So actually, when I was in 11th, he was transferred again. So he was transferred to Bilaspur in Himachal Pradesh
Okay.
from Ranchi. So I was actually starting my class 12 at that time. So he left, and I and my mother stayed back. My brother, of course, at that time was in Delhi University. He was also in Ramjas. He did physics honors as well. And then during the last year I was there, and then of course I sort of thought that I'll write the JEE exam. If I get in, it's fine. Otherwise, I'll do physics as well, because I was very interested in physics.
Right.
It just turned out that I didn't qualify the JEE, and so I decided that I should do physics. So I was enjoying physics. I did physics in Delhi University, as you said, in Ramjas College, and there were a lot of very interesting things that I was learning. There was this entire thing on quantum mechanics and special relativity and all that. I was reading deep into that, and so my brother told me that why don't you there's this exam at that time in IISc, Indian Institute of Science used to conduct that. That was a 4 years integrated ME, but the evaluation was via an entrance exam in physics and maths at the graduate level. So why don't you write that, and it will be just a good preparation, because maybe you might want to write GRE or AGRE, that kind of thing, to go abroad for a PhD in physics. So I wrote that, and somehow I got in. And once I got in, then of course there was this thing that you have got into a good place, so why don't you go? Why don't you go and join?
Right, sir.
so, so then, because I was selected in this electrical engineering department, and then I came to IISc. Of course, the first 2 years, I should say, were very difficult for me, because I was reading all these very interesting things on, and learning about quantum mechanics and special relativity and all that. And suddenly I had to change my direction. And suddenly I realized that I had to stand for 3, 4 hours doing engineering drawing and things that I somehow did not like at that time. And because you have this mindset now that you are doing some things very interesting in physics, and those things are interesting you, and suddenly you see that the things that are not very interesting to you, or maybe that should have happened earlier, did not happen at that time, and now you are into this situation. So first 2 years were tough. I mean, even the basic courses I didn't like so much. In electrical engineering, there was electronics and all that. I was more of a mathematical bent. My mind was more mathematical, of a more mathematical bent. So from third year onwards, we started getting good courses. I mean, so there were these math courses, and then there was stochastic processes courses on stochastic process optimization. Then of my own, I did a lot of courses in the math department, because I was very interested in mathematics, in analysis and all that stuff, linear algebra, those kind of things I did, which other students did not do. I mean, they were more interested, they were interested in engineering. They did engineering courses mainly, but I was more interested in the math domain. I mean, because coming from the physics background, I was more inclined to the math kind of thing, and then of course the physical interpretation of things and so on, which sort of interested me. Finally, I realized that, of course, then I ended up doing a PhD from IISc itself, and then of course, yeah. So after that, I went abroad for a postdoctoral education. I think so I spent a few years at the University of Maryland, and then at Free University in Amsterdam for a year. And finally, of course, I spent a semester at IIT Delhi. I mean, I came as a visiting faculty first, and then in the meanwhile, I got placed at IISc in the computer science and automation department. So that is where I am now.
Okay.
Yes, yes.
Professor Bhatnagar, we can see your profile is highly interdisciplinary, sir. Like you did in physics first graduation and then electrical engineering, and now in
Correct.
computer science and automation department.
Correct.
So I want to ask you, sir, is it possible for any science graduate who is done his graduation in physics or mathematics to
Yes.
think of becoming faculty in engineering departments like computer science department or electrical engineering department?
Yes, that is possible. I think we have so people who do like I think MSc in physics or MSc in math. So earlier, of course, IISc was offering this integrated ME program,
Right, sir.
integrated Master of Engineering after BSc. So
Okay.
that was a 4 years program, which is what I did. Later on, they stopped it. But if you, but other even otherwise, people who do let's say MSc in physics or MSc in maths, they can do MTech as well. And then after that, once they write, I think GATE in computer science paper, if they are interested in computer science, all the relevant, I think there are requirements. For instance, ISC has its own, different departments have their different requirements. That even if you have a science or math background, I think if you write the GATE sort of thing and clear it, I think you can still make it. If not the MTech course program, I think at least the MTech research, there's also an MTech research program.
Right, sir.
And then on, if you are interested, you can do a PhD and so on. So there are possibilities. I mean, it's
Into
not,
that.
yeah, yeah.
Okay.
So people who are interested can certainly get in. Yeah, there
Right.
are ways in which, yeah.
Professor Bhatnagar, my next question was related to what you just now mentioned. We see that
Correct.
there are courses of higher education like MTech, sir, and then we see the courses which is called MS. And
Yeah,
in IIT Bombay, IIScs, they are called MTech Research. So, sir,
yes.
I would like to ask you that what is the difference between the MTech courses and MS or MTech Research courses?
Yeah, I would say that the MTech courses, the course program is as such is more broad based. It is more course based. So in the sense that you will do a lot of courses and which will be broad based. So like for instance, our department has three streams. We have, and that will be true of any other department, say IIT Bombay, IIT Madras, any other IITs or other places. And these three streams are largely theoretical computer science, and then there is systems, computer systems and software. And then the third stream is to which I belong. This is the we call it in ISC the intelligent system stream. Sometimes in other departments they may call it AIML or something like that. So these are broadly the three streams. So these students who do MTech in courses, they actually do some courses in all these three streams. Okay, so in that sense it is more broad based. And finally, they have to do a 1 year course project in their final year. And so they then after that they decide after going through all this coursework whether which area they are interested in and what they would like to do in which discipline, that kind of thing.
Right,
The MTech research program is more focused and it is more research driven.
right, sir.
So they will initially have some idea itself at the beginning as to which stream they will be joining.
Right, sir.
So for instance, if someone is joining intelligent system stream, so in the first semester they will do some courses related to their own area of research. So
Right, sir.
that will give them good breadth and foundation in their and then they get started on their thesis work. So
Okay.
maybe they may get started even after the first semester itself. They just do
Okay.
probably one semester of coursework, maybe four courses, and after that they get started
Right,
immediately.
sir. Right, sir.
So the number of courses is not so high, but then the more emphasis is put on on the thesis, that
Okay.
what they have actually done in terms of research
Right, sir.
in the MTech research program.
Okay,
Yeah.
that's
Correct. Correct.
Professor Bhatnagar. Yeah, the department in which you are presently professor, that is Department of Computer Engineering and Automation. So, sir, I do not find this name actually in other IITs. Like computer science department is there, but what is the significance of automation word with this department name?
Yeah, so our department actually started out as a center first. It was the center for, I think it was called the Center for Automation or something. That was in 1968 sometime. And then I think in 60s, no, sorry, it was called the School of Automation. So School of Automation is how it started. In 1971, it became a department. I mean, earlier it started as a center and then it was given the status of a department. And in 1986, the name was changed to Department of Computer Science and Automation. So the School of Automation essentially was because at that time there was a lot of emphasis on control theory. I mean, there was many people who were actively involved in control systems, control theory, and so on. They were actually part of this progress of this center at that time. So that is why this automation came in, this word came in, and this continues. I mean, so because in '86 the name changed to Computer Science and Automation. So that is why we decided to. I mean, the people at that time decided that we should continue with this name
Right, right.
because this is a sort of a signature name for the CS department of IISc, that there's
Mm,
something that they have this name as automation because they, and of course automation is now coming back in a big way because
okay,
we are sort of everywhere looking at this automation term. So I think that's is also quite relevant
very well.
in our
Okay.
present context. Yeah.
Professor Bhatnagar, I see many professors in IIT, including directors of some of the IITs like IIT Bhilai. I see
Okay.
that they are graduate in electrical engineering and then they have done their doctorate from this very department, Computer Science and Automation Department, IISc Bangalore. So I was wondering whether, sir, it is a natural choice for electrical engineers to join this department, or students from other stream like let's say mechanical engineering, civil engineering, or other branches can also join this department. So what do you say, sir, about this?
No, yes, you are right in some sense. I mean, we have also seen students from many disciplines. I mean, not just electrical. Electrical, of course, a close electorate to for electrical engineering. CSA, our department is a very close fit. People see how the kind of work faculty do is not very different. I mean, so in terms of focus, I mean, at least some of there's a good intersection of people between departments, like the electrical engineering, the electrical communication engineering, the computer science and automation, and so on. So as I said, there's a good intersection of people between these departments who do similar kind of work. I mean, so it's not very different in that sense. In terms of flavor and so on. So, for instance, AI and ML is being sort of the work in AI ML is being carried out in many departments in
Right,
CSA, EC, electrical. There is also the computational data sciences department that has now started. Some people in management studies are also involved in some AI ML kind of work and so on. So yeah, so there are a wide variety, wide cross section of departments where people are doing this kind of work. So yes, and as you rightly said, we have seen actually students who have chemical engineering background, electrical background. They all have joined our department for PhD or MS, MTech research, and so on, and have done very well. I mean, so
okay.
that's something that is. Yeah, so that should be acknowledged. I think there are people who have really done well and made a big name for themselves. Yeah,
Okay,
so,
okay. So,
yeah,
Professor Bhatnagar, related to your answer, I would like to ask two things, sir. Number one, the student, like you said, chemical engineers, they have come and joined, and they have done very good also. So, sir,
yeah,
do they find some kind of handicap because they are not from those branches, like electrical background or something, which naturally fit into computer science and automation? So, a
mhm,
student who is from, let's say, sir, textile, or who is from agriculture background, or who is from chemical background, so
yeah.
is it handicap for him to join this department, or he can prepare himself during graduation to join this department in future?
No, the point is there are two ways of looking at it. One way is, of course, that obviously that person who is coming from a very different background will not have the kind of required, let's say, computer science skills or computer science background that is required. But then that person would possess some other skills, like if I take my own example, I mean, I graduated in physics, and then I came to join electrical engineering. But then I had a very different kind of an academic background myself, and sort of I applied. Sort of my way of thinking was somewhat different than the usual engineering students would. And I think somewhere these things sort of flourish and people do, I mean, their own thing comes out in the end. So I think in that sense, if we view it positively, they can pick up the background and at the same time, they need not follow the herd. I mean, so they can sort of create something for themselves, a name for themselves, their own individuality can get reflected in the work they do and so on.
Okay.
And that is becomes evident. I mean, one of the good things about our department is we give a lot of freedom to our students to explore and so on, and give them a lot of. Once we give them freedom, they also come up with excellent
Excellent.
ideas and so on. They sort of
Right.
do very well. Yeah.
Okay, okay. Professor Bhatnagar, you just now mentioned that certain courses like artificial intelligence, machine learning, data science, so these kind of courses are not being taught only in one department, but so many departments of ISc.
Yes. Yes.
So, sir, if some student wants to pursue his higher education in these kind of courses for a better
Mhm.
career, will he not get confused, sir, that in which department should I apply, or what is the criteria? Suppose somebody wants to join artificial intelligence, where he should apply, in which department?
Yeah, so actually, more recently, maybe in the last okay, so last year or so, we started actually in August 2019. We have started an MTech in artificial intelligence
Yes.
and MTech program in artificial intelligence, and that is being run by four departments:
Okay.
CSA, and then ECE, electrical, and there is a DESE department. So the electronic systems engineering. So there is electrical engineering, electrical communication engineering, electronic systems engineering, and then computer science and automation, of course.
Right, sir.
The four of us have come together and we run this program. And we have been seeing that excellent students are coming and so on. I think every year more than 40 students join the program.
Right, sir.
And they are excellent. I mean, they are top rankers in GATE and not just computer science, but also electrical GATE and so on, and they all come and join. I think that's actually very heartening to see.
Yes.
So students who are interested in doing, let's say, an MTech course work in, and they are interested in artificial intelligence, so that's actually a good program. If they are interested, they can alternatively join our computer science and engineering program, MTech and CSE,
Right, sir.
and still do a project in artificial intelligence and so on. So those things are possible. If they are in electrical, of course, they will have to then figure out. There is, of course, an MTech in electrical, and then I think with the relevant people, for instance, electrical, EC, and CDS, and so on, they will have to figure out talk to the relevant faculty members and do a project with them
So
if
that
they are
is
interested in more in AI kind of
right,
thing.
sir. Right,
Yeah.
sir. So, Professor Bhatnagar, now I would come back to, sir, your research area. So, I was just going through your biodata and your web page. In that, I
Yes.
found that your research areas, if I'm pronouncing it properly, Stochastic System Lab, you're also heading, sir, that lab.
Right.
And then Stochastic Control is your one of the research area, Vehicular Traffic Control, Smart Grid. So, I would like you to tell us something about your research domains, sir, research areas.
Yeah, I think basically I work in this area of stochastic systems. I mean, largely we look at stochastic control, optimization, and so on. The idea is that you have any system which has some element of randomness, which means noise, and dynamics, which means that it does not remain time stationary, let's say, or maybe let's say that in some sense there is dynamics in the system. Okay, so let's say there is dynamics in the system and there is noise in the system. So any such system, I mean, think of it as I mean, wherever you look, there will always be dynamics and there will be noise. So, for instance, if you are driving on the road, you will encounter there's all kinds of traffic, everything, many things happening, and so on. There are these vehicles coming from the front, and then you have to navigate around, sort of move in a manner as to avoid the traffic and sort of move ahead. And so, such a system is just as simple as driving a car is a stochastic system, because you are driving, you're trying to control the movement of the system in this random environment. And there is dynamics, there is randomness. And so, how do we get to our destination without getting hurt or in the shortest amount of time? And so, let's
Yes.
say that is our objective. So, that
Yes.
is all of this can be modeled as a stochastic system.
Okay.
I mean, if you think of any engineering application like communication networks, for instance, so many times we are interested in problems where you want to do some scheduling. I mean, let's say there is some limited resource like bandwidth is available, and there are many competing objects. Let's say there are these many people want to make use of this link of this limited bandwidth that is available. And then there can be questions of someone is willing to pay a higher price for the same bandwidth, and then you need to decide how much of bandwidth to allocate to which person and so on. So of course, and during the transmission of the call, there will be randomness because there may be other connections using the same bandwidth, and then and downstream there may be some congestion and so on, and therefore there may be delays. All kinds of things will happen. So all of this comes under this area of stochastic systems. So it's actually an extremely general sort of area, and it's very widely applicable, not just in computer science but also in engineering systems, also in sciences and so on. I mean, so it's quite sort of very broad based sort of area. Yeah.
Okay.
Yeah.
Sir, you are using this word optimization along with stochastic. So are they the similar things, similar terms, or what, sir?
No, optimization is sort of trying to optimize on or trying to find optimal behavior or optimal way of doing things. So for instance, if we are, as I said, there's this. So in a sense, how do we achieve the best way of doing a certain thing? So let's say we are in this situation where we want to control the movement of your vehicle, let us say, and you have this traffic that is coming from all directions, but ultimately you want to navigate your vehicle. And so we do it optimally in the following sense that you sort of you don't hit anyone else, nor should you get hit. And and also you sort of keep in mind that there are these traffic rules to follow. You shouldn't be breaking the traffic lights and so on. Just because you have to reach there the earliest does not mean you should just violate the traffic rules and get hit. So basically, all of this, when we talk of an optimization problem, there is a certain thing called the objective function that we want to minimize.
Right, sir.
And this objective function will depend on our parameters that we specify, right? I
Right, sir.
mean, and then there these parameters will take values in some constraint set and so on. When we talk of stochastic optimization, the objective function is also, you can view the objective function as, let's say, the expectation of a noisy cost function. The cost function will change. Let's say the queue length of that you observe on a certain road, that will change with time, because at different times you will see different queue lengths of vehicles that are standing at junctions. And ultimately, the goal might be to how much of, let's say, at what time maybe you should be driving so that you encounter the least expected queue length. Okay, so
Right, right.
that is that can be an objective. So many times we don't even observe the objective. So if you say I want to minimize the expected queue length, or let's say figure out at what time is the expected queue length the minimum, then this is something that, well, from experience you can make a guess, but then you cannot say for sure that what is the when is the expected queue length minimum unless you actually measure it. But you don't have an analytical form for the expected queue length. We don't know what it is. And so you can only estimate it using maybe your own observations, or maybe if you run a simulation, you have some simulation that is running. And based on that, you can get an idea of what the expected queue length would be, and then you can try to minimize that. So there is also this entire class of algorithms that go under the name of stochastic approximation algorithms.
Right, sir.
And this is something that we look at. So with there, the idea is you don't even, if you have an objective function, which is like the expectation of some noisy objectives, then we don't even try to, estimate the objective function itself. We just say that we'll run an algorithm which will converge to the point at where the objective function is actually minimized.
Okay.
And so this algorithm, such algorithms go under the name of what we call as stochastic gradient descent schemes or stochastic gradient search directions. They move in that direction. And that is actually an important thing because in order to get to the minimum of a certain objective, if you don't know the objective, it's not necessary that you should compute the entire or estimate the entire objective. Okay, if you just run this algorithm, it will by itself converge to the minimum, and we
Right,
can prove that it converges to the minimum.
right, sir.
So that's actually the important thing there.
Mm.
In that sense, we also get a lot of computational efficiency while working with these kind of schemes.
Right, sir.
Uh, uh,
Okay, Professor Bhatnagar, you are also working on, sir, smart grid. So, can you please elaborate this term itself, smart grid? What's the meaning of that, sir?
Now, the idea in smart grids, of course, is the following: that well, we get power from the main grid, of course, usually. In smart grids, usually what is done is, the that we can also generate power. And if we generate power from, let's say, solar cells, or by putting solar cells on our house, or maybe put it using wind farms and so on, there are various ways in which power can be generated. And if we generate power, then there are various challenges there. One challenge, of course, is that how do you store it? And there are ways or technologies of storing it. I mean, you can store it in a battery or thermal capacitors and so on. So you need to decide in what form, and then you will be storing power. And then the challenge is that power generation is intermittent. I mean, so for instance, right now in Bangalore there is sunshine, but after a while it may become cloudy,
Mm.
and sometimes it may even rain. I mean, so these days we don't really know when it will rain, when it will be sunny, and so on. So sometimes when it is raining, then of course, and it is dark and so on, then of course you don't get this generation of power. So it's not as though you can generate power every time, and when there is sun, you can get a good amount of power generated. When there is no sun, there is no power. So you have to store when energy and then make use of it for consumption in the local loads and so on. And that's what people do abroad, that they would use it for their own local consumption and that kind of thing. Now, there are some interesting challenges that one can, or research problems that one can look at in this domain. And let's say one of the problems could be that if I generate my own power and I have, let's say, excess of it, I am generating more power than I can store even. Then can I sell my power to maybe some other microgrid that is in need of power? So see, the requirements are quite random because they depend pretty much on sudden arrival of demand. So some household may have a certain demand of, they may connect it to maybe some electrical connection they may have, or maybe some washing machine has to be run immediately, or maybe, of course, these are small things, but if you have factory kind of environment and there's sudden demand that is there, then the question is, well, if you are falling short of power, how do you allocate? So one question is, well, you can get power from the main grid, of course, but then if you want to avoid that at a lower price, you can get power from, let's say, microgrids. Then questions of how much of pricing, what should be your pricing strategy? In what manner should you, what should be your pricing decisions? In what manner should you price power and so on, so that you get the maximum, you can make profits, and also let's say maximize your maximize your profits. Let's say that is the goal. Now, if you would sell power at a very high price, then of course no one will buy it. So you have to sell it in a reasonable manner also.
Right, sir.
So how do you make those such decisions? And those decisions are not something like one time. You cannot say that this is the price at which I will sell and be done with it. it's they have to be done on a sort of, you have to revisit those decisions on a regular basis. For instance, today you may be selling at a different price, maybe 5 hours from now you may be selling at a different price, and so on. These are these dynamic pricing algorithms that one needs to look at. So there are many challenges. One is how do you organize? There are these asynchronous distributed algorithms that one needs to look at, because there are all these microgrids that are generating power, and then you may be wanting to, one grid may be requiring more power than it can generate, and therefore another grid should be willing to sell it, and then at what price, and so on.
Right, sir.
Many challenges arise, and
Right.
while sending power, all of these, you also need to take into account the fact that you need to that there shouldn't be a lot of communication, because then it leads to privacy and security issues, and so on. Those kind of things also get
Right.
in. Yeah, yeah.
Professor Bhatnagar, we would like to ask you, sir, related to your recent projects which you are handling, which are having some industrial application or something.
Yeah. So I have one right now with the DST. I have one project on microgrids itself that is currently running. Uh, and then yeah, there are some projects with local companies and so on. We do a lot of work in this domain of robotics.
Okay.
Because I am also an associate faculty at the Robert Bosch Center for Cyber Physical Systems, which is a center at IISc, an interdisciplinary center at IISc,
Okay.
where of course many people from various departments. I mean, CSA is of course we have 4 faculty members from CSA who are associate faculty members, including myself, in the Bosch Center, and then there are associate faculty members from ECE, from mechanical engineering, from aerospace engineering, and so on, many departments. And then yeah, so the work we do there, of course, is more interdisciplinary, and we get to interact with many people who are, let's say, who are experts in, say, robotics and so on. So of course, my expertise is more in the learning theory side of it.
Yes.
I work in, let's say, things like reinforcement learning and so on. So in the Bosch Center, we have also, manufactured some robots and so on. And we have applied some learning algorithms to see their movement and various things. I mean, so these are very interesting sort of challenges that we are looking at in the
Okay.
center. Yeah.
Okay.
Yeah.
Professor Bhatnagar, I would like to ask you, sir, since you mentioned about many problems related to the research work which you are doing.
Mm.
Sir, can you please elaborate, or can you please mention some of the areas where there exists some entrepreneurial opportunity, and technocrats, those who are doing research, whether BTech students or MTech PhD student, they can think of entering into entrepreneurship in those areas. So can you suggest some of such domains, sir?
Yeah, in fact, a lot of our students, I mean, are now becoming entrepreneurs. So, in fact, one of my own students started a company, and which is incubated inside ISC itself. Um, yeah, so in this area is actually full of possibilities. I mean, so if you have an idea, I mean, essentially you can see many of these people who are who start out with companies and so on. They are interested in applying learning theory, because there's a lot of potential in learning theory as such. Um yeah, so they do a lot of work, and in terms of, there are particularly in robotics area and so on, there are these companies that are starting out. I mean, our own at Bosch Center also we are starting. So I think there is some company that is getting started as well.
Okay. Okay.
Yeah. Yeah.
Professor Bhatnagar, IISc is one of the best institute in India, and in fact, it is ranked highest in India for pursuing higher education. Sir, I suppose some student from very ordinary college in India has a dream to pursue his higher education in IISc. So, how he should prepare himself to join IISc Bangalore kind of departments in which you are, sir? If he suppose he wants to join computer science and automation department and work under you for PhD or masters, so how he can prepare himself? What he should have?
No, one thing is, of course, yeah, so there are two ways or three ways in which they can come in. One is if, so for instance, if students are doing BTech
Right, sir.
in some college, and then they can, see, first thing they have to do is to write the GATE exam.
Right, sir.
And the GATE exam, if they have to come in CS department for doing masters, let's say MTech in CSE or something, then they have to write GATE in CS itself,
Right, sir.
and they have to get a these good score essentially. But usually it is they. I mean, we get applications from usually the top 100 GATE rankers and so on. So they have to prepare very well. I mean, that
Right,
is
sir. Right,
so
sir. Right, sir.
really that is what it is. And once they have done extremely well and got, let's say, in the top 100 GATE rankers or that kind of thing, then they should apply, and I think they should make it. I mean, that is how it is. The other thing is MTech by research and PhD. So again, if they have done BTech, again they should write the GATE exam, and then from that pool who applies to us, we shortlist some people who are called for interview. And of course, so for instance, it is normally quite a large number of people who are called for interview. Almost 600-700 people are called for interview during over a 5-day period in the summertime. And then from that 600-700 people, we get about 30-35 students who join us. And so they are so the interview is happens in a two-stage process, and they are called for interview on a given day. So initially they have to write a written exam, which is for 10 marks, and that exam is like just to test their fundamentals in some broad topics that are relevant, that might be relevant to them. And it is a 10-mark exam. After that, some shortlisting is done from there, and the people who are shortlisted are called for interview. And in the interview, they are tested on their fundamentals. So it is important for students that if they are interested in a particular area, for instance, if they are interested, let's say in AI ML, then they should be comfortable. They should have, yeah, they should have a good background in probability theory. I mean, what we test are the basics. That the basics are clear. Probability theory, linear algebra, those kind of things, and these kind of math topics. Once they have their basics, we are convinced their basics are fine. Then that is it. I mean, so I think they are more or less. It is certain that they will make it. So that's
Okay,
yeah.
that is how it is.
Yeah.
Professor Bhatnagar, there are other institutes also in India like IITs and all. And when some students join IIT, normally IITs may students join for a good placement. I mean, after they do their courses, they get good placement in industries or something. So placement is a focus for students also, and maybe placement department of IITs also, which we do not see in IISc. IISc may placement, obviously they will get good job because they are from IISc, but the focus is somewhere else, sir. So I would like to know through you, sir, that where IISc may, where is the focus? I mean, why we are preparing, what we are preparing them for, why what we are providing them so that they are ready for what?
Yeah, you ask a good question. No, so one thing is we now have a very active placement cell in ISC.
Right, sir.
So earlier also we had a placement cell, but now there has been some revamping and so on. So our placement cell is extremely active. One thing that is useful to know is that our students are registered 100% placement.
Right, sir.
So it's so particularly in the CS department, usually in the first few weeks, everyone gets placed, and so that is placement is usually not a
Not a
problem. I mean,
problem.
so
Yeah.
the point is, well, as you say, where the focus is, I mean, our focus is more on training our students. I mean, our focus is not on getting them a job. I mean, they will get a job. And so our focus is not as though we have to get them a job by putting some extra effort kind of thing. No, no, they don't need an extra effort. They will get it. It's just that we want to optimize on their learning experience while they are at ISC. So even if you look at our courses, so our courses are designed in a manner, that we lay a lot of emphasis not just on the foundations, but also thinking beyond the book. I mean, not just focus only on the book, but think beyond it. I mean, try to create your own knowledge in some sense, if you can. I mean, so it's not necessary that everyone, ends up creating their own knowledge, but that sort of thing is also emphasized. So, for instance, many of our courses have a course project kind of requirement where the students can actually we tell the students, particularly in many of our advanced courses, that they have to not just read papers, but also not just read and maybe implement what is there in the papers, but also come up with something new, something based on that. Can they improve on the design? Can they do something that is remarkably different? And so on. And it's not that everyone is able to do it immediately within a 3 or 4 month course duration, but we do see quite a few surprises. I mean, so then during the course of our lectures, we realize there are students who can come up with something very smart, and a lot of papers get published because of the interaction of students with faculty during the courses while the course is running.
Yes, sir.
And that those are in high quality conferences and journals and so on. And so that's actually something remarkable. So we focus more on the learning part of it and the
Right, sir.
advancing of knowledge rather than getting placed somewhere. I mean,
Right.
that's anyway that will
They will
happen.
get it.
So
That they get. That's true.
yeah.
Professor Bhatnagar, I want to ask you a question. I don't know I should ask or not, sir, but ISC has a reputation that whenever somebody registers for PhD course, then it takes a lot of time in ISC, and that is one of the reasons student even fear pursuing doctorate from ISC. So I want to take your opinion on that, sir. That why so long a time is required to complete PhD course from ISC?
It's not a very long time. See, the point is, I also tell my students that you should spend maybe 4 years to 5 years. I mean, that is like the optimal time.
That is the
And
optimal time.
usually
Yep.
we see that students do get, many students do finish in 4 years to 5 years time.
Okay.
I think our average is more like 5 years and 2 months or something like that.
Right, sir.
At least in the engineering average for
Right,
that
sir.
amount of time taken.
Right, sir.
See, the point is there are two ways of looking at it. One way is, well, let us rush through the PhD program. Let's let everyone pass it off, finish it in 2 years or 2.5 years, and be done with it.
Right, sir.
And the point is, it's finally it's a degree. That's true, but then there's the tallest degree. I mean, there's nothing
Yeah.
beyond a PhD. I mean, there's
Right,
no
sir.
other degree.
Right, sir.
And then the idea is that once you have that degree, you should be able to stand on your own,
Right,
right? I
sir.
mean, it's not as though you still need a guide, you still need to talk to someone before you can create your own problems and try to solve them and so on. Should be just that you are now a PhD, and you should step out in the world and sort of
Yeah.
write your own problems, write your own projects, write your own things, and just work by yourself. If you are able, you should demonstrate that. And I think our training is geared towards that, to try and make our students to be self-dependent once
Right, sir.
they come out of their PhD program,
Right, sir.
that they can stand on their own feet and be counted as good researchers.
Right, sir.
And I think but it's not a very long process. I mean, so it's not that yeah, some people can take long time, but on the average, the time is
Four
still
to five
about
years.
5 years. I mean, which
Okay.
is okay. And so
Right, sir.
some people actually take less, maybe in 4 years, 4.5. There are many people who do it in 4 years, 4.5 years kind of thing, their PhD.
That's true.
Some people may take 5.5 years kind of thing.
They can take more.
Average.
Professor Bhatnagar, earlier for PhD student, only master's students could have joined PhD. But recent for the past couple of years now, even BTech students are permitted to join direct PhD. What is
Mm.
your take on that, sir?
Yeah, no. So the yes, BTech students are also they can also join. I mean, once they do well in the interviews and so on, we actually encourage them. If we see that they can, if we make a judgment that they look like they are sharp enough to do a PhD and sort of do it. So, but what we do is for such students who are coming right after BTech, we make them do a large number of courses
Right.
so that we need, because ultimately they have not done masters, so we
Right, sir.
make sure that they do a larger number of courses, and once they have done that number of courses, then of course they
It can
can
be done.
start.
Hmm.
Yeah. That is.
Professor Bhatnagar, I would like to ask you now this last question, and that is related to, sir, academia industry gap, which we normally talk about. So, sir, there are industries which are having lot many problems, and for which they look for some kind of academic solution. And on the other hand, sir, we have academicians like you who have wonderfully done in their own research domains, and they have some technologies which can be commercialized. But sir, there's exist the basically gap, and once this gap is plugged, we will find the solution to industries problems also, and we can commercialize the intellectual property created by scholars like you, and that will lead to lot many employment generation also in the country. And in our opinion, I think that is the solution to a great extent to the problem of India. So sir, how do you think that problem can be resolved? How this gap can be plugged? How can this gap be reduced?
The gap I see is already reducing. I mean, over the years, I have seen, that this gap has gone down. I mean, earlier when, during the time when this liberalization happened, that was in the early 90s, late 80s, early 90s kind of thing, when companies, the software companies started coming and establishing themselves, particularly in Bangalore and surrounding areas and so on. At that time there used to be an extremely large gap. I mean, so in terms of what people would expect of you, and from people who are doing their masters or whatever from places, and what was actually required in the industry. Now I see there are a large number of companies who are actually actively involved in R&D, and who are actually publishing papers, who are in the sort of they have people who are doing research, who are into active research kind of thing, and they want to learn more and more about things like reinforcement learning, machine learning, and all and AI kind of thing. So I think the gap is already reducing, and probably once it reduces more, then probably this will be even better. And it also helps academia in the sense that we get to, once we interact with the industry, we get to know their problems, what problems they are looking at, and where they are stuck, and so on. And then we can offer our own insights and solutions, which they actually take back and look at, and it helps. It's actually a mutually beneficial process, and that is how many of us in the faculty here, they do these projects, let's say consulting projects and so on, with these industries, and it's a mutually beneficial sort of a thing. We are actually in the process of already getting problems from the industry, helping them out, and also they are also benefiting from interactions with us.
Okay, that's great.
Uh,
So, Professor Bhatnagar, I have come to an end of my entire questionnaire, sir, and I'm really thankful to you for sparing your time, and you have wonderfully answered all the questions, sir. And once this interaction is published on YouTube, I'm very sure it is going to benefit thousands of the students over there.
Okay,
So,
thank
I
you very
thank you
much.
again and wish you very good health, sir.
Yeah, thank you very much, sir. Thank you.
Okay, thank you.